What's the date today?
Today is the 10th.
September 10th?
Yep. Hello, that for you. That's your cool boots.
Yeah.
Those are fine.
Table strips, yeah, good thing I wore jeans.
You're gonna learn to walk a wider berth around that thing.
We're taxing the tables.
We're making rainbow fire today, people. Oh, her face lit up.
I've heard of that.
It's
I wanted to do it so bad.
well, we're doing it.
So we're not having a big enough yard.
Yeah, stick it in your folder over there, yeah. And the binder part is fine, sure.
I don't have a big enough. I don't have a big enough yard.
Well, we're doing it in the kitchen, so.
My kitchen isn't big enough either.
Yeah, do you have a fire pit?
No, I live in a tiny rental.
So no fire pit in the backyard. Fire pit's a good time.
I used to have a fire pit in my front yard.
Got it. We'll be doing it, and it should be fun. Hopefully my little demo works well. Y'all's will for sure work well.
Didn't we have this for physical science?
Yeah, this will be up a lot. Now that it's up, you'll see it a whole lot more.
Till until the year ends.
Yeah, almost. It's up a lot.
Wait. When's midterm?
Midterm is, I think it's December 15th this year.
Let me see. That's
It's,
a couple days after his birthday.
there you go. It's right before.
December 17th is my birthday.
There you go. Oh, you're taking an interim on your birthday?
Yeah.
Happy birthday, you miss.
No.
I need
I
to
really
get
wish I
this
did good
microphone
on
real quick. I'll be right back, people.
I really want to pass. Thin Mints Girl Scouts. I brought them to my team, but we can't really share snacks and laugh. Unless we put a trope. It's an edible again. Yeah, that's she always wins. Well, yeah, nobody ever. She's gonna get like 10 smart, like 10 packs of Smarties out of her.
What now? Oh, Annabelle?
Yeah, she always wins it somehow.
A lot of the time, she's the only one that's turning one in. That's how she's winning. She has no competition.
Oh.
She's only had competition like once or twice. Y'all gotta give her some competition.
Okay.
You got girls.
Yeah, they're from my team.
Were they in the freezer?
They were in the
I was gonna say, that's not Girl Scout cookie time of year, is it? I say usually a little later. I don't know.
No, my grandparents.
Uh-huh.
Girl Scouts came to our church.
Oh, yeah.
And cookies. These are my.
I used to have a cookie dealer, at church. She was my dealer, and I went to her every time I needed some cookies. And then, when BSA opened up to girls, she joined BSA and was the first, I think, in her entire troop to get, first girl to get her Eagle. But then she was no longer my dealer, and I was like, excuse me, Madison, we're looking at cookies from now on. Like, you have messed me up by joining Boy Scouts. So.
Miss Danny?
Yeah.
Will your dad come for one of the lessons?
I'll be here for
Jokes
Christmas.
were really fun.
Oh, he thinks they're hilarious.
Like the, wait, what kind of car drive. What kind of penny is a car?
Oh, yeah, the 2 pennies. Do you know what kind of, what kind, what's he say? What kind of fruit do I have? A pear? Do you see any police? There's 2 coppers. Do you see any snakes? There's 2 copperheads. Do you see any cars? There's 2 Lincolns. Yeah, that's one of his favorites. Although he tried to change it recently and he's doing it with nickels, which doesn't make much sense because the only one you can do is a pear. But he doesn't seem to understand that anymore. So it's like, oh well.
Pennies are the only pair.
Yeah, pennies you can do lots of stuff with, but nickels you can't get very far.
On the way here, my dad made a joke.
Oh,
It was, what if your DOG actually made
that was a joke.
and it literally exploded my brain. I tried so hard to think.
Oh my goodness, that's funny. I don't know, Travis, that one needs a little work.
And then I said, what if the word COT actually meant dog?
Oh my goodness.
What?
I don't know, she's so silly. That's funny. Well, hey, you never know, man.
Is chemistry for the junior lab rats very short? Like the hard's only 45 minutes.
Yeah, your class is shorter and your lessons are not quite as in-depth or as complicated. Wrong kids. Yeah. Lydia. All right. Cool, just waiting on Annabelle.
Where's Annabelle?
I don't know.
I know she comes a little early or something. Danny,
Yes.
is it a short lab today?
No, it
It's
should,
only 2 pages.
yeah, but there's a lot of steps that you repeat. It should take about the full length of a little shorter, hopefully, because I do have a demo and I want to be able to do the demo, so. The Dave lab, there should be, oh, hang on. The Days lab should be full of opportunities for everybody to get their hands on something at least once or twice.
Hi, I'm Miss Danny.
Hey,
When the morning. Hey, I thought. Oh, is that? By the way, I saw that video. Mom showed me the video you posted a couple of weeks ago of Ozzy eating Skittles. It was so cute.
Oh my gosh, he was ridiculous, wasn't he?
I just thought it was cute.
Yeah, it was silly. If y'all didn't see it, my goofball dog. Somebody had a runaway jelly bean or a Skittles. They kind of danced off into the pub somewhere, and of course he found it. And then he was chewing it, and he got it stuck in his molars. So for a good 5 minutes, he smacked his lips and licked everywhere, and he kept looking back. I don't know why he's looking backwards over his shoulder, like it was somehow gonna magically dislodge the stickiness.
How come it says -2?
That's a -2, lost 2 points, wherever that's written.
Why?
So, if you need help reading, the person. Oh. There we go. But I tried to, you're learning. So I tried to take off as few points as possible at the end. And that's something else to remember. So remember this, your lowest lab grade for the year is dropped. So if there's a lab you don't do as well on as you want, remember that one will not count. One lab will get dropped. So, but the way the calculation works in T-shirt, usually if you're looking at your average, it's only gonna show you, it'll show that dropped lab as calculated as part of your average until we get to the end of the year, and then you'll really know which lab is dropped. It's gonna drop whichever one is currently your lowest. So say you got a 30, God forbid nobody get a 30, but say you get a 30 on one in October, it'll show that as the dropped one, unless you get a 25 in November, and then it's gonna show that as the dropped one, right? And when you get to the end of the year, whichever one is lowest remains dropped. So, and anything, if you're getting like A's and B's and everybody got an A or a B on the lab, then you'll be fine. So I graded real gently this lab. Here's the trick. I wrote this note on a couple of y'all's labs. I love your shirt, Everly. That's adorable. It says ninja. That's great. Perfect day for it. As you can see, our periodic table is out.
Yeah, I've seen her wear it before.
So something for labs and for tests and for anything in here. If you so much as attempt an answer, I can give you partial credit. But if you leave something blank, I can't give you any credit for it at all. But if you even attempt, even if you're way wrong, you know, even if you just write like, I think it might have something to do with XYZ, okay, I give you partial credit. I try to give as much credit as possible across the board. I try not to let, I'm not big on like trying to give people low grades. And things with labs is like, I can't make the lab itself, like, you still conducted the experiment, you get credit for that, right? You still were active up there doing stuff in the lab, so you get credit for that. So when you complete the lab, the actual paper lab, if there are things in it that aren't right or that are wrong or that are missing, I try not to take like tons of points because I don't want you to like do poorly on the lab as a whole when it was the paperwork that wasn't perfect. I don't know if that now may not be making the slightest bit of sense. Are we ready, people? It's 10:01. We ready to go?
Yeah.
All right, so today we're talking about changes in matter. Now, lesson 5 means we are halfway through our first 9 weeks.
And
So
I saw
that's
in the Bible,
great.
Unit 2 test.
And our unit 2 test is coming. Yep, so you have a test this week. This will be your first test that's over some cumulative work that we've been doing for several weeks, as opposed to just your unit 1 test, which is really only 1 lesson. Yeah.
So, there's this YouTube channel called Mr. DeMayo, and every time like someone says, and there says helium to this blue puppet named Andy, he pops down sections and stuff of a balloon, comes up and says a bunch of weird stuff about Mr. DeMayo, like all he talks about is chicken parmesan, or his eyes come carry on suitcases when traveling abroad, or
All right. Well, I do like chicken parmesan, but let's do our lesson, okay? All right, so we're talking about changes in matter. This is our last unit 2 lesson, and then you have a test. And we'll go over how to study and everything. So what happens to a substance in a physical change? That's the first question we gotta ask ourselves. All right, so we'll get there. So physical changes, they might alter the form or appearance of a substance, but it does not change the substance into any new substances. So what about it do we say doesn't change? Do you know? The substance is what?
The substance won't change.
Yeah, the substance is properties, but you know what I just realized? That should be an apostrophe. Yes. So the substance's properties do not change. So remember we talked about properties of matter. So its density and whatever, usually those kinds of things, they don't change. So here's ice. So a physical change might be melting. What else? What else could ice do?
You can directly make the ice to evaporating.
Which is called what? Do you remember?
Sublimation.
There you go. Sublimation. What else could it do?
You could like, put it in like frying pan or like you could boil it and it would turn into gas.
Yep, so that would be sublimating, just like he said. Yep, all right. Or and a little bit of melting probably too. So physical changes, a substance that has undergone a physical change is still the same substance that it was before the change. So here's your example, your paper airplanes. If you had a flat piece of paper and you folded it into an airplane, it may change its like its physical appearance, but it's still paper, right? Okay. All right. So how do we know the following are physical changes? So not chemical, but physical. So let's have a look. Crushing a can. Somebody tell me. All right, Emerson. It's still a can. It's not anything new. Very good. How about chopping wood, Lucy?
Chopping it up.
You're chopping it in half. Is it still wood? Okay, very good. All right. How about breaking glass, Eunice?
It's just a thing. It's just glass.
It's still just glass. It's just smaller pieces of glass. All right, Annabelle, how about dissolving sugar in water?
It's still sugar, it's still
Mhm.
sugar, it's just and water to make the water.
Right. So do you remember a couple of weeks ago when we separated the salt and water solution? We separated the salt out of the water in lab, our separating mixtures lab with your sodium, what was it? Sodium chloride and what was it? Potassium yeah. Potassium nitrate, that's what it was. So when we did that, we separated those two out. So another clue that something is undergone a physical change is that it's a mixture that you can separate by physical means. We didn't do anything chemical to that, did we? We just cooled it down and changed the phase, right? And well, really we didn't change the phase. We changed their ability to crystallize and bond together. So anyway, all right, let's see. How about boiling water? Everly, how do we know that's a physical change? It's still water. It's just in the air. Is there water in the air right now? Yes. How do you know? How can you tell that there's water in the air in this room? What could you do? Real easy.
There's probably some water that turned into gas, it's like.
Oh, it's definitely here.
Water bottle.
Probably, if you want to know if water is in the air, you just look at the clouds.
That's a good way to do it. How about if I took my drink here? I love this color. This is my favorite. It's just a little drink mix with some caffeine in it because I need that in the morning and coffee makes my tummy hurt. So if I put a bunch of ice in this glass, what would happen to the outside of the glass? Why?
Because the water in the air is
Yes, because the water in the air would condense. It would change phase from gas to liquid and it would stick to the outside of the glass. We call that what? What's that phase change called? When it goes from gas to liquid. Condensation. All right. How about sublimation of dry? Okay, what is sublimation of dry ice? Do we know what that is? Do you know what that is?
You heat it up.
Do you know what dry ice is?
You
So dry ice is when they take carbon dioxide and they cool it and compress it to the point where it looks like snow, basically. It looks like a snowball. And this is the stuff. Yeah, you can put it in water and it makes bubbles and it like makes a fog. Or you can put it in, if you put it in soapy water, it makes bubbles that are like, they look like a mad scientist.
Yes, same. Was dry ice?
Do you want to know a great great way to see what happens if you sublimate. So if you want to do something really fun, okay, this is really fun. You can do this. You can buy a dry ice at Publix. And maybe we'll do this. We might do this year when we get to gas laws, we might do this because people use it for shipping things in the mail that need to stay cold. Like if you're shipping food, people use dry ice because it doesn't melt, it sublimates, it skips the liquid phase entirely. So if you put it in a cooler and you open the cooler later, you're not gonna have water, like if you put ice in it, because white ice is gonna melt, you know what I mean?
Yep.
And then it gets wet. So dry ice is a good way to ship stuff and it stays dry. So let me tell you, if you go to Publix, and we might do this when we do gas laws. I tried to do it the last time I ran this class, and I think it was because of COVID, we didn't end up doing it because we were out that day. But if you take just a water bottle, you know, your little Dasani bottle or whatever, all right? And you put an itty bit of water in it, just a couple of drops, you don't need to put much in there.
And then you tighten it
Well,
up.
then you put some dry ice in, and you should wear gloves or use a tool because dry ice is very cold. It's so cold that it will like freeze and leave like a freeze burn on your skin. And you only put the water in because it helps it sublimate more quickly. It raises the temperature a tiny bit. You put the lid on it and you throw it way out in your yard and you just wait. Now, what do you suppose is gonna happen when that condensed, solidified gas sublimates and becomes, well, condensed carbon dioxide goes from a solid form to a gas form?
It will like boom.
Yeah, it expands. When gas sublimates, it expands. So that little plastic bottle will explode like a bomb. It goes bang. I mean, the noise is crazy. It's so fun.
At my old house, I shook up a can of Coke
Uh-huh.
and then I threw it in our.
That's fun.
Threw it in our forest. that we
Yep.
had.
That's fun.
And then, guess what the next day?
Yeah, ants.
Dried Coke all over the tree.
That too. What were you gonna say?
Like what, there's a video where you put a bag of chips in dry ice and then you eat it and then you can and then
Yeah. So if you go to anybody ever been to the nitrogen ice cream places? So there's a couple of the nitrogen ice cream places and they'll put they'll put the liquid nitrogen like into, it looks like a Captain Crunch Berry, sometimes a little round cereal, but they'll dip those in it. And if you pop that in your mouth, you can go and breathe fog like a dragon. All right. How about this one? Mixing sand with water. How do we know this is some sort of a physical change? It's not even a phase change. How do we know?
still remains.
You can still separate it, right? If you leave it long enough, the sand is gonna fall to the bottom, right? And the
then
water,
is gonna evaporate.
right? Or what? Yeah, it will eventually evaporate if you leave it out. How about shredding paper? Emerson,
Well, it's still.
it's still paper. Hang on, Annabelle. Let's stay with it over here. All right. How about melting an ice cube? Emerson again. It's still water. And Everly, you want to give me this last one? Mixing green and red marbles.
Separate.
You can separate them. That's the right answer. You can separate them by a physical means. Therefore, it's only a physical change. So what happens in a chemical change? Okay. A chemical change, which we also, AKA means also known as, right? A chemical what, Annabelle? Atta girl. Chemical reaction produces new substances with new properties. Look at him. He is up to something. I'm not sure what.
And he is half bubbles.
He looks like he's not an evil scientist, so I'm happy about that, but you never know.
Give him a mustache.
All right, here's some chemical changes. So tell me how do we know that cooking an egg is a chemical change?
It turns into a food that
It-
it is
yeah.
a food, but like it boils and
Mhm. It's a new substance, right? Right? So what happens when you cook or heat proteins, and there's proteins in an egg, right? It's called denaturing the proteins, and it breaks down the protein molecule and makes it into something else. And that's called denaturing proteins. When you eat food that's been cooked, you're eating protein that's been denatured to some degree.
Jenny,
Yeah.
when you heat up raw milk, like all the
The fat and the proteins all separate. Yeah? Mhm. Yeah, so that's another thing. So good point. Most of the time, if you're eating milk, if you're drinking milk you get at the store, your milk's been pasteurized. And what that means is they pass it through heat very quickly, just enough to kill any bacteria. If you've ever watched how like a commercial dairy runs,
they actually shoot fire at the cow udders for a second before they pop on the milking machines. It doesn't hurt them because it's real fast. It's like passing your finger through a flame, but it's enough to kill the bacteria. And so we drink generally pasteurized milk. And here's why pasteurizing is important. So it denatures, like we said, right, the membranes around the bacteria. So bacteria are cells and they have a little membrane, and that membrane's made of proteins. And when you denature it, you break it down, and then the bacteria can no longer reproduce, which means they can't make you sick. Also, alcohol denatures protein membranes, which is why hand sanitizer works. Because you're putting alcohol on your hands, so any little proteins that are there denatured. Viruses are made of proteins, they're denatured, so it kills your bacteria. You can't kill a virus because the virus isn't technically alive. It's a weird little thing we'll get to in biology. But there was a movement in, I want to say it was the late 90s. There was a company, it's still out. This company's still around. It's called Odwalla. Anybody ever had Odwalla juice? You can buy Odwalla juice. It's usually in the fridge section, like in the produce part of the store. Well, Odwalla had this thing where their apple juice, that they weren't pasteurizing. It was all fresh, not pasteurized, meaning not passed through a flame, no bacteria killed. It was supposed to be fresh and not processed apple juice. There were several people who died from drinking it, and they died from drinking it because they got E. coli poisoning. Now, this is interesting. E. coli lives typically in your colon, so in your intestines, in your body. You can find E. coli in poop, but you don't want to eat that because in the upper part of your digestive system, it wreaks havoc. It'll make you so sick, you throw up, you get diarrhea, and so much that you dehydrate, you can die from it. It's really bad. It can make you really, really, really sick. Well, how do you suppose apples on a tree are going to get a bacteria on them that comes from poop? Well, I'll tell you how. Because the people who were picking the apples for the Odwalla company to make into apple juice were picking them off the trees, but they would look at the ground and there were some perfectly good apples on the ground, and they're like, oh, this one looks good, and pick it up, throw it in their little picking bag and go on. Well, you know who else was picking up apples off the ground? Deer. And as their deer are walking along and eating apples off the ground, they're also pooping on the ground. So people were getting E. coli from their apple juice because it had not been pasteurized. So, but you have to, you can get flash pasteurized, which means it's real fast pasteurized, and that's also safe, but there's some types of microbes that continue to live. But, most of the stuff you're going to get in the store has been fully pasteurized. Yeah.
Okay, so do people still did they start pasteurizing the apple juice?
They did after that. Mm-hmm.
Yeah, because they probably got sued.
They did. You are correct. Absolutely right. That the market worked in that case. They did. They got sued. It was a big deal. Company almost went under, but somehow it survived. But yeah, their whole thing was, we're not going to pasteurize. We're going to be good. And now they're like, well, we changed our minds. Maybe pasteurizing is a good idea. And pasteurizing, by the way, that word doesn't come from pasture, like where cows walk around. It actually comes from a man named Louis Pasteur, who's a French dude, who really, he did a lot with microbiomes, and he's microbes, sorry. And we'll get to him in biology, but he's very important. Yeah.
He discovered that dangerous microorganisms could grow in water.
Yeah, he made a lot of discoveries. He's real important. Okay, let's just keep going. How about vinegar and baking soda mixture? How do we know that's a chemical change, a chemical reaction takes place? Yeah.
It's like a chemical reaction.
Yeah, how do you know?
Because it launches.
Okay, so when you see it bubbling, that what's being produced? Something's being produced that wasn't there. What makes bubbles? It's a gas that's being produced, right? You put a solid and a liquid together, suddenly you have a gas being produced because you see bubbles. So that gas is a new substance. It wasn't there before. It's actually carbon dioxide that's produced. Anytime you mix a base and an acid, in this case, baking soda or sodium bicarbonate is a base. Vinegar is acetic acid, that's an acid. If you mix those two things together, you always get water, a salt, and a gas. Always. That's what happens when you mix an acid and a base. All right, how about electroplating? Anybody know what that is?
Is it like when you put electricity in?
Kinda. Do you know what it is?
Is electroplating like the water goes through the electricity, so that makes a new substance?
So what happens is, you ever seen anything and you look at it like a piece of metal and you read it and it says like it's silver plated? or nickel plated. So what they do is they put it in a bath of usually like a salt water because it's more conductive, and we'll learn about that soon too. And they run electricity through it, and there are also some manner of whatever metal they're trying to get on the outside. So usually it's like maybe it's composed of nickel, and then they're going to put silver plating on it. There's like free silver floating around in the water, and then that electricity causes it to adhere to the metal, and then you get silver plating. All right, how about burning wood? How do we know it's a chemical change? Emerson? Turns into something else. You get a new substance. You get ash, and you get, yep, smoke. Yep, there's solids in smoke. When we do our cigarette thing, there's solids in smoke. You'll see them. Fireworks. How do we know that's a chemical change? What do you think?
It turns into gas.
Yep, there's a gas, and there's also a production of color, light, and sound, right? How about baking a cake? How do we know that's a chemical change? How does it start? Batter, and the batter turns into cake. Is that a new substance?
Yes.
Yeah, it's a new substance in this case. You've denatured proteins again. Rotting banana.
Yeah.
How do we know that that is a chemical change?
Because the bacteria is formed and it turns into a
Mhm.
new.
Bacteria get to it eventually, but what starts out is there are certain, believe it or not, plants have hormones too. It's not just teenagers, plants have hormones too. And those hormones in the plant, there is a particular one that causes ripening. And when it ripens more and more and more, does the banana change color?
Yeah.
Yeah, that's a new substance. Does it smell different?
Yes.
Yes. Okay,
Yeah,
chemical change.
That's actually how like you
Teenage
have
banana.
Yeah. And
I
this is
actually like, went to a fireworks show on the 4th of July with some of my friends, and it was so fun.
okay. So also that's how you can tell that's a chemical change, and that's the same chemical change that happens when anything organic rots. Even people.
People,
Yeah.
People rot after they die. Right? Yep. Anything rot. If you're organic, you're made of carbon and you're a living thing.
So
Those are organic compounds. You will rot when you die. Now you rot a lot less if you've been embalmed, but you still. All right. How about iron rusting? Ooh, if you don't take care of your cast iron pans. What do you think, Emerson?
I can't turn it back.
Yeah, you can't take it. Yeah, you can scrub it off, but it's a new substance, right? It's called oxidation in this case.
Oh.
Chemical battery. Oh. You ever put a battery in a toy? Does it last forever?
No.
No, it runs out of charge because there's a chemical reaction going on the whole time. All right, and then lastly, oh, here's a big one, metabolism. Metabolism is your body's, it's kind of like your body's engine. So you eat food and somehow it gets converted into energy, right? So there is stored energy in the food and you convert it into energy that you're using. That's definitely a chemical reaction. It's a new substance. You produce waste, don't you? You expire when you breathe out. You're breathing out more carbon dioxide than you took in. You're breathing in more oxygen than you put out. All right, so let's look. When learning about chemical reactions, it's important to remember this law. Matter is never created nor destroyed. That is the law of conservation of matter.
the law of conversation of matter.
Yeah, the law of conservation of matter is never created nor destroyed. It only changes form.
Energy.
Yes, law of conservation of energy, law of conservation of mass, law of conservation of matter. They're all basically the same concept. Never created nor destroyed, only changing form. So remember, matter is anything that has mass and takes up space. So this law applies to chemical reactions. In a chemical reaction, mass is neither created nor destroyed because matter has mass. So now we have a law of conservation of mass, right? And then let's go over some signs of chemical reaction. So you guys mentioned a lot of these. We just talked about a lot of these. So let's have a look. How do we know a new substance is formed? What do you suppose this might represent?
Color change.
Color change. Yep, that is a sign of a chemical reaction, a color change. All right, how about this? What does that look like? What do you think, Emerson?
Stink.
What does it look like? Yeah, say it. Smelly shoes, production of an odor. What makes your shoes smell? The bacteria eating your sweat and stuff that you leave in your shoes, your dead skin cells and your sweat in your shoes. Those bacteria are like, this is delicious. I'm going to eat it and I'm going to fart it out. And that's why it smells. For real. Yep, for real. That's also why armpits smell. Ugh. All right, what's this one? This one's a tricky one. Do you know? So this one's tricky. This is production or formation of a precipitate. A precipitate is when you have a solution, you drop another solution or some other liquid into it. Somehow you combine two liquids and a solid forms. And we're going to be doing this a couple times this year. You'll create precipitate. You'll see it happen. You'll have like a nice clear liquid and you'll add some other clear liquid to it. And suddenly you can see it turn cloudy and you know there's a solid now mixed in there. That's a precipitate. All right. Oh, sorry. That one is evolution of a gas. So this is what we were talking about with vinegar and baking soda. When you put vinegar and baking soda together, you get bubbles, right? There's a reason for the bubbles. That's because a gas is being produced. All right. Now, what do you think this one might represent? What do you think? This one is a change in temperature. Oh, yes. Remember we talked about the little hand warmers that you can squish and shake and the little ice packs that you can squish and shake. One gets hot, one gets cold. There's a change in temperature. And somebody mentioned elephant toothpaste. Elephant toothpaste, you ever seen that? People mix stuff together.
Yeah.
That gets hot too, right? So change in temperature is a
Cool, that's
Yep, yeah. This is a sign of a chemical change. Okay, now what about this one? What do you think, Emerson?
no stick.
Light, production of light.
Oh, yeah,
Yep.
there are two different substances, and when you break them, they mix together. And then
Exactly right.
but they mix even
Two,
more when you shake them.
two different substances, you break them, you shake it up, and you get light, because now you have a chemical reaction that produces light. Are there any living organisms that produce light? What do you think? There's one I'm sure you've seen, you've probably caught in your hands. What do you think?
Those night fireflies.
Fireflies or lightning bugs, yeah?
And the ocean.
Lots of different animals in the ocean. Do you know what we call that?
That's bioluminescence.
Very good. Bioluminescence is what we call it when you have a living organism that produces light. And they do that by conducting chemical reactions inside their body that produce light. And some of the coolest ones are the little tiny, like, well, I was gonna say there's some cyanobacteria, which is like algae types that glow, and you get water that gets full of them, and the water at night will glow, like all of the water, because they're so small that you don't see. That's not like a jellyfish, because you know jellies will light up sometimes too, but it's like all the water glow.
I've caught a firefly and it saw the light. I went to a dark room and it saw the light glowing.
Fireflies are really cool because they light up their little butts, right? Their little abdomens light up. And they actually they use it for communicating with one another. The males and females flash at different rates, and that's how they talk to each other.
Are you supposed to turn in multiple pages?
What are you talking about turning in? Your binder work or your lab, or what is it? I can't see.
My binder.
No, leave your binder work always in your binder. You're going to need it to study with. Okay. Somebody had a binder work from last week that got left here by accident. It's in the lost and found. So if you turned in, it's one of you guys. So if anybody turned in binder work or left binder work here, be sure to go get it. Guess them.
Here's $5. Break if you buy it. What if you broke one of the glow sticks to test if it worked?
I guess you
You
buy it.
have to buy it.
I guess you buy it because now nobody else gets to break it.
What if nobody knows?
Now let me ask you something about a glow stick. If you snap a glow stick, how long does it glow for? Forever?
No.
No. What
It only goes
happens?
for like a couple days. Not a couple days, like
Well,
10 minutes.
Depends on the glow stick, but it doesn't go forever. That's because you have two different substances in there reacting with one another. And once they've all of the compounds have come in contact with each other, there's no more reaction to happen. There's no more light production. So if you shake it, sometimes you can cause some that have not come in contact with each other to come in contact, and then you get your chemical reaction to continue. But once they've all reacted, they've all reacted. Yeah.
Okay, but if you can't turn in, but if you're not supposed to turn in your binder work, then, but you are supposed to turn in your binder work, then what do you do?
No, you never turn in your binder work. Always keep your binder work so you can study. Always
But
keep
I
it.
thought that counts as part of your grade.
It does, but you know how I know you did your binder work? Because you're answering questions. That's how I know. And then when you get that weird question in your homework that says like, you ever look like a celebrity or whatever, that says to me, okay, Miss Danny, did Annabelle answer questions in class? Yes, she must have done her binder work, then you get credit. That's how it works. So when you do the baking soda and vinegar and you get the foamy fizzy stuff, does that go on forever? No, because
it's
once
not.
everything's done reacting, it's done reacting. All right, how about this? What do you suppose this is? We've had production of light, so Everly, what do you think? You know, I tell you what, I broke my dog because I took him with me to a fireworks display when he was little. And now every time he hears thunder or fireworks, he gets panicked because he gets scared. Why is he getting scared? Because he's what? He's hearing. So production of what? Yeah, sound. There you go. Production of sound, production of noise. Yeah, making noise. What's actually happening there is that chemical reaction is so hot that it is expanding the air really fast. And that's just like thunder. That's what you're hearing is the boom, the concussion of the air knocking into other air. All right. And then how about this one? Oh, what's this? What do we think? Do you want to go, Beverly? There you go. Yes. Absorption or release of electricity. So when we saw that chemical battery a minute ago, that's like a battery you put in a toy. Production or release of electricity is a chemical reaction. All right. So if you look at your binder work now, we'll go through these and make sure that everybody has their answers. So who has number 6? Who wants to tell me what's there? Emerson?
Energy stored in the chemical bond between atoms.
Yeah, so that's letter C, right? No, wait. Letter C, temperature. Oh, are you looking in the right place? I think, oh, you're looking at A. Okay, you read A. So C goes with 6. That's what we're looking for. So measure that temperature is a measure of the motion of the particles in a substance. Heat is the transfer of that energy, right? So things may feel cold or warm depending on how energy is transferring, but temperature itself has to do with the motion. So number 7, what letter goes there, Lucy?
F.
F. Okay, very good. So that means that a change in which energy is released is an exothermic reaction. Exo, energy is released. Okay, number 8, what do we have? Oh, Everly. A, there you go. Energy stored in chemical bonds between atoms is chemical energy. What's an endothermic change, Eunice?
B.
B, a change in which energy is absorbed. How about thermal energy, Emerson? D, yep. Total energy of all particles in an object. The law of conservation of mass, Lucy?
E.
E, yep. The fact that matter is neither created nor destroyed in any physical or chemical change. You keeping up, Annabelle?
Oh,
Okay.
yeah.
12, physical change, Everly?
H.
H, alters the form or appearance of matter, but does not turn matter or substance into another substance. And lastly, Lucy?
G.
G. Okay, there we go. A change in matter that produces one or more substances. All right. Yes.
So it's C F A B D E G E H.
C F A B D E H G.
Yep.
Okay, good. All right. Now, how about these? Let me show you these real quick because we're going to move through. So it's a physical change, C for chemical change, and PC for both up on the appropriate line. So P is physical, C is chemical, PC is for both. So occurs when energy is added or removed is both physical and chemical, okay? Because chemical, we talked about like electricity being produced, right? Right, added and removed is both. Chemical is a new substance is produced. Physical is a substance changes form but remains the same substance. Physical is freezing and rusting is chemical. Okay, how are changes in matter related? I'm watching our time. We need to keep moving. So chemical changes. Every physical and chemical change, that should say in matter. Ooh,
Brownie point.
I caught it, not you.
No, I said it says M-A-T-E-R.
Oh, Mater. Oh, you did catch that one, yeah? Oh, wow. Not Mater. He's cool, but that's not what we're talking about.
Later.
All right, there you go. So you got to write that one down for me. Includes a change in what? Anybody know what goes here? Every physical and chemical change in matter includes a change in which thing?
Energy.
Energy. That's right. Okay, includes a change in energy. So energy versus temperature versus heat. Thermal energy versus temperature versus heat. So your thermal energy is your total energy of the particles in a substance. Your temperature is a measure of the average kinetic, and what's kinetic energy? You should know. What is it?
It is the energy that you're moving.
Yeah, energy of motion. So it has to do with motion. And then heat is the transfer of energy. We give thermal energy in joules. That's the unit we use, joules. Joules. Yeah. Energy is used for thermal energy. We use joules.
I know what
For
the
temperature, we use Fahrenheit, Celsius, or Kelvin. And heat, you can use joules or calories. Now, let me tell you something. When you read, like my Big Mac has 9 million calories in it, it's not calorie. When we talk about food, it's actually kilocalories, which is 1,000 calories. But we don't write kilocalories on food. So when you read calories on food, you're really reading kilocalories. I don't know why we do it that way, but that's how we do it. And then lastly, thermal energy is going to vary with mass and temperature. Temperature does not vary with mass and temperature, and heat varies with mass, specific heat capacity, temperature, and change. Okay. In a chemical reaction, chemical bonds are either broken or formed. Okay, sometimes both. Breaking bonds requires energy. Forming bonds releases energy. So here's how you know what's going on in these reactions, all right? If energy is absorbed by a reaction, heat in this case we're talking about. So if energy is absorbed by a reaction, energy goes in, the reaction's endothermic. If energy is released, you're breaking a bond, forming a bond. Yep, you're forming a bond, energy is released, energy out is exothermic. Endothermic reactions feel colder than their surroundings, and exothermic reactions feel hotter than their surroundings. So here is a question. Think for a minute. All right. The main chemical reaction that takes place in your body that has to do with how your body is fueled and powered is called aerobic respiration. It is the opposite chemical reaction of photosynthesis. Basically, you're bringing in oxygen and sugar, and you're doing something with them, and you're producing energy on the other side. So is it an exothermic or endothermic reaction? What do you think overall?
I think it's the energy out is exo.
Yeah. You know how you know?
Because
Touch yourself. Touch the couch. Are you warmer than your surroundings? Ah, you are. So that is an exothermic reaction. Yep, you are exotherms. All right, now, I want you to look here. These are your Unit 2 test study topics. You can write these down. You can take a picture of the TV, or you can go to your student Dropbox. And in your student Dropbox, there's a folder that says resources. And in there, there's a folder that says Unit 2 test study topics. And this picture is in there.
And one more thing, you can go to the YouTube channel and look at the video.
Yeah, you can look at the videos. There's lots of videos. So let's go over them real quick. Now, not always am I going to have time to go over all of these, but we'll go over these. All right, so we just talked about physical and chemical changes. If I gave you an example of something, could you tell if it was a physical or chemical change? So how about this? How about this? Bobby decides he's gonna grill a hamburger. So he takes his hamburger meat and he smashes it into a patty and he puts it on the grill. And now he has a nice cooked hamburger. Did he cause a chemical or a physical change? A chemical change, yeah, because what happened?
Because the protein.
Yeah, the protein, yeah, it changed changed form, right? I mean, not form, changed substance. Now it's cooked protein. All right, let's say he puts a slice of cheese on top and the cheese gets nice and gooey and melty. Chemical or physical change? Physical change, very good. So there might be a question on your test that has an example like that, where you have to tell something chemical happened, something physical happened, what was it? Okay, very good. All right, so what are some signs that we just went over? What are some signs of chemical changes? Somebody give me one. What's a sign? Yeah. Of a chemical change. We just went over a whole bunch of them.
Baking soda and vinegar.
Yeah, but what's a sign?
Sign.
Yeah, how would you know?
Color change.
Color change. There's one. What's another? Yeah,
Heating.
change in temperature. Yeah. What's another? Chemical
Change in
change.
sound.
Production of a sound. What else? Somebody give me one.
Change in
Production of light. Very good. What else?
energy.
That's usually going to show us heat, but you're correct. How about production or release of
Gas.
electrical energy? Gas. There's another. What about stinky shoes? What?
Odor.
Sound. Yeah. What about shoes? Stinky shoes.
Odor.
Odor. Right? These are all signs of chemical change, right? All right. If you put toast in the toaster and pop it out, do you notice a color change?
Yeah.
Okay. Keep that in mind on your test. There might be something about toast on your test. Okay. States and phases of matter. Give me an example of a state of matter or phase of matter. What's an example of that? There's 3 common here on Earth that you deal with every day, and a 4th one you don't see as often. Gas is
water,
one.
Solid.
Solid's another. What's the
Water,
3rd? Emerson?
liquid.
Liquid. What's the 4th one that we only kind of see so
Fire.
often? Plasma, like lightning, right? We don't see it very often. Solid, liquid, gas. What is it called if you go from a liquid to a solid? Freezing. What is it called if you go from a solid to a liquid?
Melting.
What is it called if you go from a liquid to a gas?
Sublimation. I mean, not-
Liquid to a gas.
I mean, evaporation.
Vaporization or evaporation, you could say. Although evaporation technically is only on the surface and boiling is through the whole thing. Vaporization is all the above. What is it called if you go from a gas to a liquid?
It is.
What is it?
Condensation.
Condensation. Okay, good. What is it called if you go from a gas to a solid?
Gas.
This is like frost forming on the grass. A
Sub-
gas to a solid.
No, it's the opposite of
It's
sublimation.
the opposite of sublimation. That's solid to a gas. It's deposition.
Deposition.
There you go. Very good. All right. Basic metric units. What is our unit for length? Our unit.
Metric system.
Yeah. What's the unit? What do we use for measuring length? We measure in what?
Feet.
Meters,
Meters.
right? How about volume? Liters is that's our unit, liters. How about mass? Grams, right? Okay, so how many? 1,000 grams is equal to 1 what?
1 kilogram.
Kilogram. Okay. Let's see. 10. Oh, here's a tricky one. 10 decagrams is equal to how many decigrams?
10
Ooh.
decagrams equal to how many? Wait, I think I got it.
What?
It's 100.
Very good, because you just go back to, remember? So go back and look at that. You've seen that graphic many times. So what is kilo? It's king. So then what?
Kilo.
Kilo,
King, kilogram.
hecto. Then what's next? Wait.
Centi.
Deca, centi, deca unit, deci, centi,
Milli.
milli. Very good.
We got unexpectedly by drinking.
Right, or unusually, either of those. Very good.
Drinking chocolate.
All right,
And
somebody
then-
tell me, so if I gave you a metric conversion, could you do it? If I said, don't put your foot on the table, baby.
Sorry.
It's okay. If I said 325 centimeters is how many meters?
You multiply centimeters is how much meters, so you
Mhm.
multiply it by 10.
There you go. Yeah, you just deck it up, right? Okay. All right. So then how about this? Accuracy versus precision. Who remembers the difference? Accuracy versus precision. So you remember? What is it? Yeah, so accuracy is how close your measurement is to the actual measurement, and precision is how close your measurements are to one another. Like if all of our lab teams measured something out and I knew the exact mass, and you all masked something, but I knew the exact mass, The accuracy would be how close it is to the mass. The precision is how close everybody's measurements were to each other, right? And precision and accuracy are both affected by your tool, right? They both are limited. All right, theory versus law. Here it is again.
Scientific.
What is it?
Scientific theory explains why it's a lot, and scientific law explains like what.
Yeah,
Why?
scientific theory explains
Tells
why
why
something happened, an explanation.
And
Scientific law explains what happens, a fact. Very good. All right, mixtures, compounds, molecules, atoms, and elements. Do we know the difference? An element is the simplest form of a substance that cannot be broken down into anything simpler. And an atom is the smallest particle of that substance that retains all of its properties, right? What are molecules? How are molecules and compounds same and different?
Compound is a type of molecule.
A compound is a type of molecule.
Which is two molecules.
So molecule is when you have more than one atom combined, but it can be the same atom. Like oxygen plus oxygen is O2. That's a molecule. It's not a compound because both atoms are the same. A compound is when you have more than one different type of atom combined,
So
right?
like H2O.
Like H2O, that's a compound, but not a well, it's a compound is the better term for that. All right, but technically we can call them all molecules, but you can't call O2 is not a compound, but it's a molecule, whereas H2O is both a molecule and a compound. I know, that's fun, right? Mixtures, how do you know something's a mixture? What can you do to it?
If you want to know if it's a homogeneous or heterogeneous,
Mm-hmm.
I think one of them can be easily separated, one of them cannot.
Right. Homogeneous is not easily separated. Heterogeneous is, okay. How do you know it's a mixture and not a different chemical substance? You can separate it using physical means. And our last one, determining density. What is the formula, mathematical formula for density?
Centimeter divided by centimeter divided by grams.
Close. It's mass over
Grams.
volume.
Oh.
Mass over volume will give you density every time. Yes, ma'am.
Why is lab 3 in the back of our?
He already caught that. That was a typo. It should say lab 5.
It's a-
So
it's a
it's a brownie point. All right, so let's bring our other people in. Yep, he caught it.
Already caught it. Too late.
He caught it. All right.
Good luck.